Here we go, guys. Well, today I'm not here today. So what we're going to do is I'm going to go through a couple of questions of exercise 10.1 and also 10.2, and from this you should be able to work through those exercises. So what I'll do first of all, I want you to go to question 9 of exercise 10.1, and I want you to have a bit of a read of it first, and we will continue on. So pause this video until you've had a read of it, and then when you had a read of it, then you press play again and we'll start from there. Now from the question, you were told the value equals and I've written down ab to the power of x because it says it had an initial value and stuff like that. So straight away we know that the initial value a was 24,000. And then it says, and then I'm going to say it decreases by 15% a day. So I'm straight away going to write the value of b down as being 0.85. Now you might say, how did you get that value of 0.85? Well, have a look over here and I'll go through it for you. If you realise 24,000 was the original value, which equals 100%. Now if it decreases, and I'll just write an arrow down, by 15%, what's really happening is, therefore, remaining amount is equal to 100 minus 85, which, oh, not 85, I'll go back a bit there, sorry, 100 minus 15, which equals 85%. So that's how I got my value for 85%. Now what this really means is that decreasing amounts are calculated by %100 minus the decreased percentage. And similarly, increasing amounts, which you've done previously, are going to be 100% plus the percentage. So it's all based around, do you add your percentage on or do you subtract it? If you subtract your percentage, you're going to get a decay function. If you add your percentage, you're going to get a growth function. Alright, so this therefore means when we go back to our original question, value will equal 24,000 times 0.85 to the power of x. And that is quite clearly our equation that we're going to use. All you have to do next is, for example, when the question say, what is the value after 3 years? All you have to do is substitute the value of 3 where the x is. So, therefore, the value after 3 years will become value equal 24,000 times 0.85 to the power of 3. Now, solving all this on your calculator, you'll get $14,739. And there's how you would go ahead and solve the first part. Now what I would like you to do is I'd like you to go ahead and try the rest of question number 9. Now I'll stop the video here, and once you finish that you can continue it on, and then I'll give you some other types of questions you can use. Okay, here's a question that you can try. A pool holds 65,000 litres of water each day. 5% of the volume evaporates. Part A says write an equation to represent this, and part B, how much water is in the pool after 6 days. Now clearly there's a relationship between volume and the days. So the key parts of this is volume and day. So they are going to be your two variables. Now, so to do this, we're going to simply put, well in fact no, let's have a go. How about you stop the video and see how you can go solving this equation. And when you reckon you've done it, start the video again and see how your solution is. Here we go. I reckon volume equals AB the X. Now it says the pool holds 65,000 litres, so that becomes my initial value. So A becomes 65,000, and B this time simply becomes 0.95, because that's come from 1 minus 0.5, as we discussed previously. Therefore, V equals 65,000 by 0.95 to the power of x. And that is my part A, that's my equation. Now, if I'm going to squeeze this in, which I will, day 6, okay, day 6 it says, what is its volume after day 6? Well, simply all we have to do is V equals 65,000. I'm going to squeeze this in by 0.95 to the power of 6, and lo and behold, when I calculate that, it gives me 47,780.97 litres. And that is how we do a decay function. Okay, here's the next type of question that you'll encounter in this exercise. Now, I've made a real short question here. So it says bacteria have been counted. It could be bacteria in a wound, bacteria in yogurt, don't care. But bacteria has been counted each day, and the results are as follows. So at day 0, there's 100 bacteria, day 1, 300, etc. The important part to remember here is, when they say day 0, straight away you know that is the value of A. Because day 0 means time has just started. So that's your value of A. You don't yet know the value of B, because that's your growth factor, because it is growing, because these numbers are getting bigger as we go across. Okay, they're getting bigger. It's not a decay one, it's a growth one. Okay, so I'm going to write that, therefore it's growth. So value of B must be greater than 1. Okay, B has to be greater than 1, otherwise it won't grow. Now the question is, how do you find the value of B? Right, so what we do basically is we're going to write our general rule. And the general rule for this case here would be bacteria equals AB to the X. What do we know? Well, we know A is 100. So, we know A is 100 because the simple fact that day equals 0. It's the start. Now, how do we find the value of B? Now, I'm going to go to another page here. So I'll just rewrite, and I'll just rewrite it. And so we had bacteria equals AB to the X. So what you do is you choose any one of your other values on the table. Now I'm just going to happen to randomly choose 900 bacteria at day 2. So therefore, by doing that, I know 900 bacteria, we know that was 100, that was A, and we know B, and we know X is 2, because this has simply come from the value of 900 bacteria on day 2, which means quite simply that's the value of A and that's the value of X. Now, when we know that and we look at our equation, what we see is we can then say 9 equals B squared, because I have divided both sides by 100. Therefore, 3 must equal B, because I've taken the square root of both sides. Now you happen to know A, now you know the value of B, so therefore the equation is going to basically be bacteria equals 100 times 3 to the power of X. So then you now have that relationship between any of those for any day that you'd like. Now, what I'd like you to do now is you can go ahead and try questions 11, 12 and 13 from exercise 10.1 because you now have all the information to be able to do that. You can now stop the video for a little while, have a practice then. When you're ready, you can then move on to the last part that we're going to look at. So stop the video now, practice them, and when you're ready, start it up again. Okay, exercise 10.2 is, once again, it's still related to growth functions, but this is what we call solving growth function equations. This is where we now have the equation and we know the answer. For example, here's our answer, but we don't know the number of times, the x value, to get to there. Now, I'll tell you right now, in all of these questions is going to be something that's always going to be similar. And that quite simply is this. Since we have 3 here, I automatically know that that number there is equal to 3 to the power of some number. Has to be. If it's not, we cannot solve this question. So, if I get my calculator out, just go 3 times 3 times 3 times 3, okay, and keep doing that, I will find that 3 times 3 times 3 times 3 times 3 times 3 times 3 will equal 2187. What does that mean? Well, it quite simply means I can do this. 3 to the power of 3x plus 1 must equal 3 to the power of 7. Where did the 7 come from? The 7 came from the simple fact there were 7 3's. That gave you that value. So now what you tend to find is, I now know that then 3x plus 1 has to be the same value as 7. It only makes logical sense. Both indices must equal each other, which therefore means 3x must equal 6, x must equal 2, and hence you have solved that question. Pretty straightforward. The key to it is simply, though, the key to it is very straightforward, is that it lies with that number there. That number must be a power of that number. So any of these questions you can solve by following this format. Now the last question I would like to do is from example of question 2. Now question 2 says solve something like 2x plus 6. Oops, that doesn't look real right. We'll make it better. 2x plus 6. Still didn't work out. Hang on. We'll get this right. That's better. And solve it graphically. Now, the simple matter of this is you get out Desmos. Now, I'm not even going to bother doing it, get out Desmos, because I'm just going to show you really quickly and roughly. If I type into Desmos, y equals 2 to the power of x, I'm going to get a graph looking like that. Well, that's the value of 1. So this is y equals 2x. And it says, and I'm also going to graph y equals 6, which means up the top up here, I've made a complete mess of this question, because that shouldn't be plus, that should be equals. Now that makes a lot more sense to me now. All you do now is, and my graph is not accurate by any standards, and I'll change colours here, I'll make this a nice blue. If that was the value of 6, that line there is y equals 6. Where the two lines intersect, that is the value that I'm looking for in this case. So that, where my question mark is, on my x-axis, is the value for the value of x. Now, using Desmos, you've only got to tap that little part there and it will tell you the value of x. So it's a very simple and straightforward way to solve these questions. So now you can basically go ahead and finish exercise 10.1 and you can go ahead now and do 10.2, and we're well on the way to doing this chapter.